All right. This is Spencer and Brady for lesson 8. I'm going to go ahead and get us started. Let me just get the screen share set up. All right, so for number 1, it's asking for the allele and centromere composition of the 4 products of meiosis if there's a crossover between S and T. So right off the bat, we already know what 2 of the products are because we can take this first one, the original, and that's going to be one of the products. And then if we go up a little just to where it tells us what the inversion is, if we reverse the inversion, that's going to give us another one. So there's 2 products already. But the other 2, you have to do a little work. So basically you're going to get those 2 from these 2 middle ones that are going to cross over. And so I'll just go with this second product I have right here. And so we're going to have our dominant, and so we're going to have LMN, centromere, OPQRS. And then that's when this crossover is going to happen right here between the T's and the S. So then we're going to have this recessive T, UV, Q, PO, centromere, NML. So that's going to give us the second product right here. And now for this third product, we're going to start with this recessive XWRST or RS, and then we'll cross over right here and we'll have the dominant, the TUVWX. And then like I said when we first started, this fourth product is just the reverse of the inversion that we're given before. So that's how you get the 4 centromere compositions. Now for number 2, fill in the blank. I'm just going to read them off. So we have A, non-disjunction in meiosis 2 produces 50% aneuploid gametes, whereas non-disjunction in mitosis can produce a mosaic phenotype. B, meiosis in an individual who has suffered a paracentric inversion produces a dicentric chromosome and an acentric chromosome. C, Turner syndrome is an example of a human disease caused by monosomy, while familial Down syndrome is an example of a disease caused by Robertsonian translocation. D, human liver cells can be 4N, 8N, or 16N. E, a terminal deletion in chromosome 5 causes Critey-Chat syndrome, while an inversion on the X chromosome causes type A hemophilia. F, a duplication is a change in chromosome structure that can be potentially beneficial to an organism or an entire species. And G, when a translocation crosses form, the alternate segregation pattern can be viable gametes and offspring. And I'm going to do 3, A and B, and then Brady's going to take over after that. So for A, it's just asking for how many chromosomes would be found in certain conditions. So for Turner syndrome, we know that we're only going to have one sex chromosome, and it's going to be an X chromosome. And so we'll have 45 total. Jacob syndrome, we're going to have an extra sex chromosome, which is going to be a Y, so it'll be XYY, and so we'll have 47. Critey-Chat, that's the one where it's got the terminal deletion, so all it's going to do is just remove genetic material, but it's not going to change chromosome count, so it'll just be 46. The familial Down syndrome, it's 46. It would have an extra chromosome, but that fuses, and so it basically just brings it back down to normal. And then type A hemophilia has 46. Their chromosome count's not affected. For B, which of the following terms is not associated with Charcot-Marie-Tooth disease type AI or IA? And so we know that it's duplication and diploid, so everything in green is not associated. So triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction. So that's how we do that. All right, go ahead, Brady.
All right, so C says, which of the following terms are associated with Klinefelter syndrome? I have all of them highlighted in red. We went with triploid, aneuploid, and non-disjunction. So the black ones are not the answers, just the red. For D, out of all the answers that I had listed, we didn't find any of them that were particularly correct. So I guess our answer on that one is going to be none. So for 4, diagram of synapsis of these chromosomes in prophase 1. So what you're going to do is you're going to line them up, and then you're going to go and you're going to do a cross between them. So you pretty much have an X between the top and the bottom lines. And then for B, you're going to identify the allele composition of gametes produced by the alternate segregation. And so that would be the top and the bottom. And you refer back to A on all of these. So that you'll go the top line and the bottom line for both of them. Then C is identify the allele composition of the gametes produced by the adjacent one segregation. I can't read tonight, obviously. And that one, you'll refer back to A again, and you'll go left and right instead of top and bottom or crossing. You'll go left to right. And then D is dealing with adjacent two segregation. And what you'll do on that one is up and down, again referring to A, your original cross. And then we'll go on to 5, which states cats have 38 total chromosomes. How many total chromosomes would be found in the following types of cat? So A says triploid cat, which triploid is 3N. In this case, there's 38 total chromosomes, so you'll divide 38 by 2, so you get both sets of your chromosomes, which comes out to be 19. So your equation will be 319, so it'll be 3 times 19, which comes out to be 57. B, a cat that is monosomic for chromosome 12. So monosomic is -1, so you'll have both sets. So you'll have 19 times 2. The equation's 2n minus 1. So you'll go 2 times 19 minus 1, which give you 37. C is a cat that has suffered a terminal deletion on chromosome 7. Pretty much the deletion does nothing, so you're still going to have 38 total chromosomes, 2 sets of 19. D says a cat that has suffered a Robsonian translocation between chromosome 17 and 18. Well, you would have an extra one, but they fuse together, or you would have normal, but they fuse together, so your answer will be 37. And then E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9. Again, that's not going to do anything, and you're going to end up with 38 total chromosomes in that cat also. So that does it for Lab 8 group problems for Brady and Spencer. So enjoy.
Sweet.